Hello student, in this video I am going to discuss about texting or mining the text or text mining. Fundamental concept is that the importance of constructing mining friendly data representation of text for data mining. And exemplary techniques are like bag of words representation, TF, IDF calculation, anagrams, stemming, and name entity extraction, topic models, etc. So actually mining the text is difficult because why? Text is often referred to as unstructured data. This refers to the fact that the text does not have sort of structure that you normally expect from data. Tables of records and with fields having mixed meanings, essentially collection of history vectors as well as links to be between the tables. Text of course has plenty of structure, but it is linguistic structure intended for human consumption, not for the computer. So we need to pre-process the linguistic structure into human understandable format. So words can have varying lengths and text fields can have varying number of words. So sometimes words order matters, sometimes not, because depending upon the model, depending upon the problem, sometimes the number of words is matter, sometimes the number of words does not matter, sometimes the length is matter, sometimes the length is not matter, sometimes the meaning is mattered, sometimes not, and sometimes the arrangement of the word is mattered, sometimes not. Also, as data text is relatively dirty. Dirty means people write ungrammatically, they misspell words, they run words together, they abbreviate unpredictably and punctuate randomly. Even when text is flawlessly expressed, it may contain synonyms. So there are various types of problems in case of text mining. But to that also we need to understand how we can mine that text. So first, some basic terminology for representation is that most of this borrowed from the field of information retrieval. A document, a document is one piece of text, no matter how large or small. A document could be a single sentence or a 100-page report or anything in between, such as YouTube comment or blog posting. Typically, all the text are document. All the text of a document is considered together and retrieved as single item when matched or categorized. A document is composed of individual tokens or terms. A document is composed of individual tokens or terms. Those tokens or terms will be the words or any punctuations or any point used. For now, think of the token or term just a word. So we will show how they can be different from what are customary thought of as words. A collection of document is called a corpus. So bag of words, it is another terminology used in case of text mining. It is important to keep in mind the purpose of text representation task. In essence, we are talking a set of documents, each of which is relatively free form sequence of words, and turning it to our familiar feature vector form. Each document is one instance, but we don't know in advance what the features will be. The approach we introduced first is called bag of words. As the name implies, the approach is to treat every document as just a collection of individual words. This approach ignores grammar, word order, sentence structure. So, the approach of creating the bag of words will ignore the grammar, will ignore the order, will ignore the sentence structure, or also the punctuation. It treats every word in a document as a potential important keyword of the document. The representation is straightforward and inexpensive to generate and tends to work well for many tasks. Sometimes we can say sets and bags. The terms set and bag have specific meanings in mathematics, neither of which we exactly mean here. A set allows only one instance of each item, whereas we want to take into account the number of occurrence of the word. In mathematics, a bag is the multi-set where members are allowed to appear more than once. The bag of words representations initially treats documents as a bag, multi-sets of words, thereby ignoring the word order and other linguistic structures. So there is a difference between sets and bags. Now, what is term frequency? The next step up is to use the word count. Word count or the frequency in the document instead of just as a 0 or 1. This allows us to differentiate between how many times a word is used. In some applications, the importance of a term is in document should increase with the number of times that term occurs. This is called the term frequency representations. Consider the three very simple sentences here in this table. Jazz music has a swing rhythm. Swing is hard to explain. Swing rhythm is a natural rhythm. So the word swing has been used too many times. So if you see the representation of the term count, here you can see D1, that A is 1, explain, hard, has is 1. Again in D2, this is D2. So whatever the words are, you can see how many it has been represented. So how many times that word has been counted in a single sentence. Usually some basic processing is performed on the words before putting them into the table. Consider this more complex sample set document. Here you can see this one complex document. We can go for term after normalization stemming ordered by frequency. Stemming and we need to understand stemming and normalization separately. You can go to the literature to understand this. But after the counting, the term are like Skype. If you go to the Skype, it will be 3 times. If you go to the approve, it will be 1 times, like that. To create this table from a sample document, the following steps has been performed. First, the case has been normalized. Every term is in lowercase. Normalized means every term is in lowercase. This is so that words like Skype are counted as the same thing. Case variations are so common, like consider iPhone, and iPhone. That case normalization usually necessary. Second, many words have been stemmed, their suffixes removed, so that verbs like announces, announce, and announcing are well reduced to term announce. Similarly, stemming transformations plural to singular forms, which is why directors in the text becomes director in the term list. Finally, stopwords has been removed. A stopword is a very common word in English. The words the end, of, and on are considered stopwords in English, so they are typically removed. Note that $8.5 is the story has been discarded entirely. Should it have been. Numbers are commonly regarded as unimportant details for text processing, but purpose of the representation should decide this. So sometimes we might need that value or need that word, sometimes we don't need that. So we need to understand in which situation those type of word might be taken in the frequency table. And again, there is another word, that is inverse document frequency. So term frequency measures how prevalent a term in a single document. We may also care when deciding the weight of a term, how common it is in the entire corpus we are mining. There are two opposing considerations. First, a term should not be too rare. For example, say the unusual word prehensile occurs in only one document in your corpus. Is it an important term? This may depend on the application. For retrieval, term may be important since a user may be looking for the exact word. For clustering, there is no point keeping a term that occurs only once. It will never be basis of a meaningful cluster. For this reason, text processing system usually impose a small lower limit on a number of documents in which terms must occur. Another opposite consideration is that terms should not be too common. A term occurring in every document is not useful for classification. It sometimes happens. It does not distinguish anything, and it can serve as the basis for a cluster. The entire corpus would cluster together. Overly common terms are typically eliminated. One way to do this is to impose an arbitrary upper limit on the number of the documents in which a word may occur. In addition to imposing upper and lower limits on term frequency, many systems take into account the distribution of the term over a corpus as well. The fewer documents in which the terms occurs, the more significant it likely is to be to the documents it thus occurs in. So the sparseness of a term T is measured commonly by an equation called inverse document frequency, which is shown in this equation, where IDF equal to 1 plus log of total number of documents divided by number of documents containing T. So this is actually inverse, because here you can see the total number of documents is upper in the upper side, or you can say in the denominator, or in the denominator you can see number of documents containing t. So that is why that value might be less also, that might be value high also. But if you take the log and plus 1, it will give some value to the inverse document frequency of a term. Inverse document frequency may be thought of as a boost a term gets for being rare. So if the number of documents containing t is less, then obviously the value will get boosted. So in the graph you can see as a function of number of documents in which t occurs in a corpus of 100 documents, as you see one term is very rare, the IDF is quite high, and it decreases quickly as t becomes more common in the documents. So when the documents is more common, then it becomes like, or its value becomes 1 almost. Then we are going for another term, that is term frequency. A very popular representations for text is product of term frequency and inverse document frequency, commonly referred to as TF-IDF. TF-IDF equal to term frequency into IDF. Note that TF-IDF value is specific to a single document, whereas IDF depends on the entire corpus. So systems employing the bag-of-words representation typically go through steps of stemming, stopword elimination before doing term counts. Term counts within documents form the TF values for each term, and the document count across the corpus form the IDF values. So each document thus becomes a Fisher's factor, and corpus is the set of these Fisher's factors. This set can then be used in a data mining algorithm for classification. So we have understand, or we have gone through various terminology regarding the mining of the text. There are other also important thing need to be understand if you are going for the mining of the text. So please go through the literatures, or go through the books here also. And there is another example is containing here, like jazz musician. Please go through this example to understand more about this mining the text. So if you find a difficulty, please let me know, or if you want to add something more also you can share it. So we'll try to discuss those things over Google Meet. Till then, thank you.